Chatty today. Happy Wednesday. Came back to a lot of chat messages. Yes, I am wearing a cape. I'm definitely wearing a cape. It's a little snug, but I am wearing a cape. I'll explain that in a second. It goes with the shirt. I came from a pretty cool event just now, where we got these sweet capes. So I had to wear it. You know, you feel fancy, you feel super. Somebody told me I look like I've been wearing it since birth, and I didn't know if they meant it was tight around my neck, like it fit my body perfectly, or if they're calling me a superhero. But either way, it made me feel good about myself a little bit. So yeah. Oh yes, it's a thing. It's a thing. BA6. It is starting. It is starting soon. We are starting. It was a typo originally. Someone pointed it out after it took like 3 streams for someone to point it out, but we're gonna leave it for now because it's exciting. You'd be surprised at how little people catch that. When I brought it up, people were like, I had no idea. We got our coffee, keep us going. But how's everyone doing tonight? We're almost through. Tonight will be the end of week 6, which is great. We're halfway through. That came up pretty fast. Let's see here. What do we have? Pretty sure it's week 6. Let me see. Coding with Python. What do we got? We have tonight. We have algorithms, part 2, and coding challenges. So I should have just changed this actually to coding challenges. I mean, they are algorithms. These coding challenges are algorithms. Oh, we do have some LaCroix tonight. We have tonight. We have fancy. We have something we never tried before called pamplemousse. Pamplemousse. This is grapefruit, I believe, and I think it's grapefruit in French, maybe. That is what we have tonight. Once we're done with the coffee, we'll hop into that. I don't really love grapefruit, but this should be fine. But yeah, we're gonna do coding challenges all tonight. We were gonna go deeper into some algorithms, but I actually found that when I was showing this to someone who didn't know Python at all, or who was like just learning Python, diving into more of the like how to solve algorithms, like I guess the structures and ways to solve algorithms, like the specific ways, again, like bubble sorts and things like that. They found that to be confusing before diving into some coding challenges. So we'll start off with some. I'll probably teach some type of sorting method tonight, just so that sorting is such a big thing for some reason in a lot of coding challenges. But we're just going to hop straight into Exorcism, and we're going to do a lot. Or not, maybe not a lot, but we're gonna get through as many as we can tonight, just so we can start to get some practice in. Because I don't think learning how to do specific sorting algorithms, do specific problem solving algorithms, will help as much as you being able to go forth and try out as many of these challenges as you can on your own. And then next week, we'll hop into some other stuff that'll help us out. We'll get into error handlings and file operations. So we'll be able to, manage files on the computer and have some, put output into files and put information into files and, handle errors when things pop up that are bad. And then we'll talk about some scripting, how we can use Python to automate some cool things, some things that you might do every day. We can go ahead and automate some of that stuff. So we're getting in pretty deep now. So about the cape, about the shirt and the cape. So I just came from an event. You can see here, there's an HB. I don't know if it's backwards or not to you. But I just came from a Hack Baltimore event. So Hack Baltimore is a civic hacking event. It's a hackathon, but it's a civic hacking event, like a citywide Baltimore hacking event, which is pretty cool, where there are like these like challenges to solve like real city problems. Hack Baltimore. And basically tonight was like the kickoff night. I don't think it's until maybe May, I believe. But it's pretty cool. They have this portal. They have this idea portal. People have been bringing forth ideas in one of a few categories. So education, workforce, transportation, public safety, housing, and health. And they're really trying to get people in the city, people who are technical, city government, things like that, to kind of come together and be able to solve some of these problems together. So I'm pretty excited about it, especially because when I hopped on here, one of the things that was on here was for education was yeah, using coding education to address wealth inequality, which is pretty cool. So I was invited to this event. I thought it was pretty dope. There were some, some cool people here to kind of kick it off and to get people excited. But we're going to be building teams, and I'm definitely going to participate in this. So I'm going to be trying to build a team. So if you're in the Baltimore, DC area, or you feel like making a trip to Baltimore, I'll have more information about it. But I'm going to try to build a team, and we're going to try to hop it. I think it's a full weekend thing. It's like it's a really big event, but we'll take a weekend and we'll try to solve some problems. So if anyone's interested, reach out. I'll have more information about it. But I got a bunch of free stuff. So I was like, I'll wear it. I'll talk about it a little bit. Cause I definitely want to participate in this. So that is where I'm coming from. That's the story behind the cape for tonight. All right, let's get moving. Let's get hands on. So 806, depending on how fast we're moving, depending on how fast we get through some of these problems, I'll probably go a little over tonight just because I want to get as much hands-on practice as we can. But feel free to kind of, at the 10 o'clock mark, head out you can head out whenever you want. But yeah. So tonight we're going to be using Exorcism. So I brought Exorcism up to you before. But now we all should have GitHub accounts now. So that's good. So it should be easier to sign up for our Exorcism account. So if you want to follow along, which I highly encourage, you should head over to exorcism.io, and sign up for an account. Again, if I log out, I can use my GitHub to sign in. You can sign up here or you can log in. So I'm gonna get logged in because I already have an account set up. And once you're in, you will be faced with a bunch of different language tracks. Oh, also, anyone looking for slides, there's no slides tonight. Again, specifically because we are going to be practicing. And I thought the slides would be too prescriptive and that we would have to go down a very specific road. And I think there's going to be some opportunity to hop around in the types of problems that we kind of hop into tonight. So you get in here and you have a bunch of available tracks available to you for pretty much every common coding language and a lot of uncommon ones as well. And they all have a varying number of exercises. Most of them are overlapping. So if you do one, if you pick one, you'll probably see those same problems as you move over to other things. Some are very language specific problems designed to challenge you in that language. But obviously we are doing a Python course, so we should go ahead and we should choose the Python track. So scroll down and find Python. Python consistently has the most exercises. They add more exercises, and they kind of swap things out every now and then. Python consistently, between Python and Go, they consistently have the most. It was Go for a little while. I've seen them go back and forth, so Python and Go. You all know that I love Go, that excites me. So if you're trying to learn some Go, you can do that. But we are going to be using Python, which I believe has the most. How many does JavaScript have? Yep, it has more than JavaScript. What else might have a lot? Okay, C#. That makes sense. C# has the most. That makes a lot of sense. Bash 86. Cool. So you click on Python here, and then you're brought to a track. You get a little overview of what this is going to be. It lets you know a little bit about what Python is. But the good thing about this site is you have two options. There are three great things that are good about this site. One is that you can get your work can be reviewed. They have mentors here. It says 110 mentors over here. But basically, you can submit work. You can download a problem. You can attempt to solve it, and you can submit it. Even if you don't solve it, you can submit it for review, and you can get feedback. It might take a couple days because again, these people are volunteers. The people who hop on and do this because they love to help. And you can get that good feedback, and you can learn through the advice of someone who is much more senior in this, and they can point out some things that you could have done better, or things that you did really, really good. So that's one thing that's great about this. Second thing is there's a lot of people using it already. So once you submit an answer to a problem, again, whether you solved it or not, you can see other people's answers, and I find that to be very powerful when you're working on coding problems. And you can look through and see how other people solve the same problem that you're trying to solve. It's really helpful. You can learn a lot from trying to solve a problem and make it nowhere and submitting that problem. And like, because you were thinking about it logically, once you start to see someone else's answer and start to break it down, there's tons of value in just the practice of breaking their problem down. But seeing how it works, almost helps you realize that, oh, like I do kind of understand this stuff. I understood the steps that I needed to take to get here. I just did not know how to do it with Python, or maybe I didn't know the steps, and I can see that all the tools that they used in Python were pretty simple, and I know how to do all that stuff. So next time I can do it. But it really helps. And again, there are a lot of exercises. It'll take you a long time to get through them. And it has a Teams function. We're gonna set up a team tonight as well. But yeah, so once you get in here, you can simply just join this Python track. And now there's two modes. There's mentored mode and there's practice mode. We're going to use practice mode. Practice mode allows you, it gives you all the problems up front and you can pick and choose which ones you want. Mentored mode takes you through a progression of problems. You have to do a problem to unlock other problems. So we're going to do practice mode again, so that we have access to everything, only because we might actually get through too many. We'll go back and do mentored mode and we'll see if we get through. You can always switch in between. If you pick one, it's not the end of the world. You can select the other. Like we can go to the bottom. I will switch back to mentored mode. So it can take us through. It can take us through the progression. Let's unlock some things because it'll feel pretty good. All right, we're here. We're ready to solve some problems, some algorithmic problems. Yeah, we're gonna practice reading through the problem. Again, take it back to the algorithms one session. We are going to read the problem and we're going to read it to comprehend it. We're going to understand what is being asked. So we're going to read it. We're going to make sure we can break it down and understand what it's really asking. And then we can start, if we have to, we can write some pseudocode. We can start mapping it out. We can start drawing things, whatever we need to do to come to our answer, we can start to do. So these are, again, they're not, what I try to tell people about these coding challenges, coding challenge problems is generally, most of them, especially like these, they're not coding challenges. They are word problems that can be solved more quickly using code. And so think about them like that. You're really trying to, if you can mentally solve the problem first, then you can develop the code to do what you needed to do. So when you're ready to work on a problem, you go ahead and you click on it and it gives you an overview of what needs to be done. So we got hello world here. Let's make sure we know everything that's asking for. The classical introductory exercise, just say hello world. Now, I will say some of this stuff in Exorcism is not written well. Some of the wording is a little bit weird. You have to read it a few times because it's not the common way that I think. Well, I don't know. A lot of the times, some of the ideas are expressed in a way that I didn't understand at first. But yeah, so you just might have to read through that a few times. There's another thing that will help you know what to do in a bit. So we're going to basically print out hello world. It looks like it's the traditional first program for beginning programming in any new language or environment. So I'm pretty sure every single first item for any of those language tracks that we would have picked would have been hello world first for that language. So this is good. So here are the objectives, and this is what you want to pay attention to. Write a function. So this is important. We know functions. We just learned functions last time. Remember, functions are those those reusable blocks of code that only execute when they're called. So we have to write one of those functions that return the string hello world. So we can't just print hello world like we would normally do. We have to write a function that returns the string hello world. So we have just combined so many of the things in this one sentence that you've learned so far. A function, we know that functions to be able to access the data outside of them, it needs to return something. So returns the string. We know that we need to return a string. We know what string. We know what a string is, a data type. And we need to return this string right here, which is hello world. Then it says, there's a little curveball at us. It says, run the test suite and make sure that it succeeds. We've very lightly touched on test-driven development. We're going to have to talk about that more tonight because All of these problems are built in a way that you need to satisfy a suite of tests. So we're going to learn that as well tonight. So that should be pretty cool, learning about how that works. And then go ahead and submit your solution and check it at the website. So we're going to create a function that returns hello world. We're going to run a test suite, and we're going to submit our solution. So if this is your first time using Exorcism, you have to run through this walkthrough to get it installed via the command line. And it can be cumbersome. I've already done it. I actually wish I had removed it. But you kind of go through. It's not cumbersome. It just does some. If you're on a Mac or if you're on Linux, actually Mac might be easier now. No, it's not. It looks like they made this better by adding screenshots. So actually, it may not be as hard now. This is good. This looks like it's better. But follow this get starting thing. So click on get started. Click which operating system you're using. I'm using Linux, so obviously I would choose Linux. And it gives me some options. I guess if you're using Linux, it might be easier to use Snap if you're kind of new to this stuff. Yeah, either one. Just run through. It should be all copy and paste. It should be all copy and paste straight on through, and it should tell you exactly what to do. Yeah. So try to take your time and go through that. We're gonna get started with the Hello World one, so I can just show you how things are broken down. Take your time, try to figure it out. You already know how to print Hello World, but I think even if you miss this one while you're trying to get this command line started, you haven't missed much at all. The next one we try will cover everything we did in this and more. So you can take your time and try to download that if you need to right now. So what you do when you're ready to try a problem, you read through everything that it has here. You'll start to realize that generally everything below, like each of them will have this exception messages thing and how you run these tests. These are kind of copy and pasted through all of them and how to submit. So you probably only need to read this once or twice. And the main problems are going to be up here before this first break HR thing down here. So first thing we need to do, we need to go ahead and we've decided we wanted to do this problem. So now we need to download it. The way that you download it is they give you a cool little command here and you copy it. You can't do this download until you've set up this piece up here, until you set up the command line. So once you have the command line set up, you have to hop into a terminal, which we will now do. And actually mine is, I'll delete the Python one. I'll delete both of these. Yeah, RF. Don't do this. Don't do what I'm about to do. Never run arm-rf star. I will try not to, unless you know exactly what you're doing. Cool. So what will happen is I took the download command here. I'll paste it. You can paste it anywhere. You don't have to be in any specific directory. You just hop into the command line and paste in what you just copied. And you can see here, it says downloaded to home, A. Brooks, Exorcism, Python, Hello World. So this is really important. So now you know where it was downloaded to. It will download to a different place on everyone's computer. I think they've changed the default directory since I set this up on mine. I've had it set up for a long time. But pay attention to where it downloads to, and then you can go there and see the files that were downloaded. Home-RF. I've missed some stuff running that in the wrong place. Yes. Yep. I've gotten a little too comfortable on running ARM-RF star. I don't know. Sometimes I just live the YOLO mindset, and it's not good. It's not always good. So you saw that I had just deleted this Python directory. It creates it for you. And inside the Python directory is this Hello World project. And let's go in here and see what's in here. All right, so we got some files in here. We have a Readme. Remember during the Git session, we talked about the Readme being the thing that's going to have the information, the instructions in it, usually on how to either run an application or instructions or whatever. We have a hello world.py file already set up for us. So looks like we already have, a Python file set up for us. And then it looks like we have a hello world test.py. So this is a test file, and we're going to hop into that in a second. What's up, Kai 90p? KEO 90p. Welcome. That was correct. Every time I struggle, I won't stop until I get it right. And I'm sure KEO 90p is the right answer. So welcome. Thank you for the follow. So let's take a look at our Readme first, because remember, Readme is generally the instructions. Maybe we forgot what we're supposed to do. Let's take a look at the Readme, and it will be better if you took a look at the Readme in, actually, if you're using Visual Studio Code, if you're using VS Code, Readmes are really nice. So Readmes are markdown files. Remember, we talked about markdown being a way to format text, really. And so if you have a markdown file in VS Code, if you hit this little button here, open preview to the side, you can see what it's supposed to look like. So you can see here, like these all mean different things. Like this is a link, but over here is what it's supposed to look like. So in VS Code, you can click that and you can see exactly what everything is supposed to look like, which is nice. So let's read it through here. This is the exact same thing as you saw inside on the website, which is great. We have it all self-contained here, and we can read through if we ever need to get back to what we were doing. Yeah. And we can go ahead and edit in VS Code today. This feels weird, but we can do it. So, would I have an update? Okay. We'll edit inside of here. Can I close this? Yeah. All right. So generally they give you a file to start with. They give you what's called a stub file, which is nice. So let's take a look at what they give us already. What do we know about functions? We know that to create a function definition, it starts with def. So we can see our keyword def here. So it looks like they've set up a function already for us, and it says def, and the function's called hello. So they've already set that up for us. And we have to, again, if we look at the Readme again, we have to write a function that returns the string hello world. And it looks like they've already done the hard part for us. They've already written the function structure for us with a pass. So we talked about passes. Passes work both in these functions and loops, and it's basically just you can't have a completely empty Python. You can't have a completely empty function definition. You have to put something in there. So the pass just allows you to basically have an empty function. It just says, all right, just keep going. No big deal. So it makes this function valid. So if you were to run the test, which they talk about below, which we're about to do, it'll be able to run the test. But it will not solve the problem that we need to solve. So tests. What are tests? Let's talk about tests really quick. Tests are a way, and these are going to be unit tests here. They're going to be a way to ensure that a function or subset of code that you've written performs in the way that it's supposed to perform. So it's a way for you to become confident that your code does what it's supposed to do. And tests are really nice. Tests, as you develop an application, it's really good to have tests because things change, and those big changes can mutate the way that a code operates. So maybe you want to check that maybe something you wrote was supposed to be returning, an integer or a number, and for some reason, changes you made, now it's returning a number, but it's returning the string version of that number, stringified instead, which will cause problems inside of your application. You can write tests to ensure that this thing is returning what it's supposed to return. So then you can find out about issues before you deploy these things to certain environments, to production. You can find out about issues, and you can be confident that your code is doing what it's supposed to do. So let's take a look at one of these test files. So it's using, I thought they're using Pytest. They're using a package called Pytest to write these things. You don't need to worry about how to write these tests right now. But we're going to keep looking at the test file because you can use these to know how to solve the problem. You can look at these tests and you can see what is expected. You can see what is supposed to be happening by taking a look at this. So the way it's kind of broken down is we've got this hello world test class. You don't know about classes yet, but you know that def is a function, and this function says test say hi. And basically it's going to do this assertion. And the assertion is basically going to run some code. It's going to run your code, and it's going to say, hey, I am going to assert that when I run this code, when I run this function here, it's going to run the hello function. It's going to basically go into the other file. We haven't talked about imports, but it's using that other file. And it basically says, when I run this function, I should get this as output. So basically when I do this as input, I should get this as output. And that'll start to make more sense. I know right now you're like, I don't know what that means at all. Don't worry about it. As we go through more and more and more, it'll start to become relevant to you. Even if you have no idea how to do this, when you see a test run, even if you're not using these to figure out how to build your code, you can use these like when you run the test to find out like what output was supposed to be, and maybe it can help you figure out where you went wrong. So before we make any changes to the code here, let's go ahead and run the tests. How do we run the tests? You can say, hey, I have no idea how to run these tests. But if you did what I said originally and you really read and you comprehended, you would see that there's a section here on exactly how you run these tests. So to run the tests, run pytest hello_world_test .py. So we're gonna copy this and we can just try to run that. We can copy it. I'll open up the terminal right here. I won't open up hold on. Shift. Oh man, I don't know how to, I can't do that. I have a small keyboard. New terminal, let's do that. Okay, so we'll paste it in. I can't remember what my shortcut is because it's not, backtick is not a key on my thing. All right, so we try to run it and you will likely get this. I try to run pytest, hello world, test.py, and it says that Pytest is not found and it can be installed with install Pytest or whatever. So we're gonna be using we're using Python 3, and a long time ago I should have helped you map Python 3 to just your Python command or aliased it, but don't sweat it. We're gonna go ahead and we're gonna install Pytest really quick. Using Ubuntu, what text editor would you recommend for Python? I would recommend either Visual Studio Code, that's what we're using here, VS Code, or what is it, PyCharm Community Edition from JetBrains is pretty good for Python. But VS Code is kind of great for everything, so I usually recommend VS Code. All right, so we can install Pytest. It's interesting they didn't put how to install it in here, which I think is weird. There's a couple different ways you can install it, but again, we're learning how to find the answer, so we can just say, how do I install Pytest? Pytest, yeah. And you'll get here, and you get brought straight to some documentation on how to do so. So we'll just click the first one because it looks like it's good, installation and getting started. And it looks like they're using pip here. So pip is a Python package installer. I think we talked about pip a little bit, and I don't think we installed it. Pip can be annoying. Do we have pip? Let's see. All right, so we have pip already. So you can use pip to install this. Let me go to pip and show you how you would install it. It's got a quick installer. The Python package installer, I'll paste this in the chat so that you can get to it. All right, and in here, you could either use a package installer here, or I know this is small, I'll make it larger in a second. Installation. So you simply would copy this command and paste it in your terminal. Then you would copy this command and paste it in your terminal, and you should have access to pip3. To pip. Yeah, should have access to pip there. So I already have it installed here, and basically this package manager will allow you to install things the same way that we use package managers for anything else. You've seen me use them for other things, but we would just do pip3 install It's default, no need to download, I guess. Oh, so I think pip, are you saying pip is already there by default? Maybe on Windows. Are you on Windows? It might be available on Windows by default. I'm not sure. Or maybe it comes with Python now. I have no idea, actually. But pip3 install with the Pytest. So when you do that, you can see a bunch of stuff is happening. I got a permission denied. If you are not watching the DevOps course, then you would not know to do sudo. But if you are watching our DevOps course, you would know that we need to get administrator access. I actually think if you would have done this on Mac, I actually think it would ask you for your password. And on Windows, it might. I don't know what it does on Windows, to be honest. All right. Wrong. Cool. So this is gonna basically download this Pytest thing for us. It's also important to note that, like, if you're having trouble getting Pytest set up, we can work with you to get Pytest set up. It's not the end of the world. You can still write the code. You can still run it yourself. You won't be able to pass this test suite. Which you should take some time to try to get set up, but again, not super important that you do it right at this moment. Okay, so now we have this set up. Let's go ahead and run what they told us to run. And actually, I'm gonna run this in the browser because not in the browser. I'm going to run the code in the other terminal because this is like, I don't know, man. I don't know why it's so jarring using this instead of Vim. I think it's because of also like how large everything is in here. I don't know. The scaling of it. Let's see. Let's go down. It's just like this. No. There we go. Cool. All right. So Pytest hello world test.py. So again, that terminal that I was in, this is the same place. You can see these are the same files that I'm editing up here. Same file. So I'm in the same directory. So it's this down here is no different from this up here. They're the same place. This and this is the same thing. So try not to get confused when I'm leaving VS Code. Okay. So Pytest hello world test.py. So let's try our Pytest. All right. And so this is what a test looks like. This is, a single test, and you get some output here. It says collected one item. So one test basically. And then it lets us know that file failed. This F is for failed. You can see here it says failures. 100%. We failed 100% of our test cases. So each case, you'll see when we get to more cases, you'll see what a case looks like. But the one that we had failed, so we failed 100% of our tests. When we go down here and take a look at it, it says assertion error. None is not equal to hello world. So let's break that down and figure out how to what that means to us and how we can use that to know what we're supposed to do. So what this does is this is our output. The first thing that it has here is what your code output. So when they ran this hello function, they basically got nothing back. They got none. The test file got none basically because when we take a look at our code doesn't do anything. It just does a pass. So that makes sense. By default, it gets none. It says that is not equal to hello world. What it said that they were supposed to be equal. It said this is supposed to equal this, and they're not equal. We know that when we learned about our comparison operators, we know that an exclamation point and an equal sign is saying not equal. And so it lets us know that this failed, and it lets us know how fast this ran. So now we can use this again to figure out what it is that we're supposed to be doing. What's up, Mar598? Welcome. Thank you for the follow. But we can use that. So it tells us what our code is outputting, and we can use that to troubleshoot and figure out what's going on. So let's make this pass. How do we make this pass? So we could do, so you might say first, you might say print hello world. Like when you're learning how to do hello world apps, this is generally what you would do. You would do print hello world. You know what? I'm moving this here. There we go. Now I can see my keyboard. Hello world. exclamation point, and you would save that. You save it, and then I could go back and I could run this. So you can see here, it fails. It fails again. You know, you're like, whoa, what happened? I know how to write hello world, but we got a none here. Why did we get a none here? We got a none here because of what we learned about. We learned something about our functions. This is running, and this does happen. And actually, you can see when we usually it would actually kick out. Oh yeah, it did run. It runs. So it's funny. It captures your standard output, so it'll show you the output of the code if you have any output of the code. So it actually does run. Hello World does actually run, but it does not solve the test case. Why doesn't it solve the test case? Because of what the README says. The README says it didn't say print out Hello World. It said write a function that returns the string Hello World. So how do we do that? We know how to do that. Let's go ahead and write a function that returns that string. So we got the function here already. We got the string here already. Hello World is the string we want. How do we return it? We simply return it. And so the first time you tell someone to write a hello world function, and it's written like this, I've seen people be confused that it did not, they'll run hello later, like they'll do this and they'll go down and they'll call hello down here, and they'll run it and nothing will happen. And that is because, again, we're not printing anything. You would have to print that entire function if you wanted to do that. So this function, as it's currently written, doesn't actually print anything to standard output, but it does, in fact, return some data. So we'll save that, and we'll run our test again. And so basically, you're going to be trying to write some code to solve the test, and then when you're ready to check for that, you just go ahead and run that same command again. Awesome. So let's take a look at this. We got another failure, so we know the F is for failure, failed 100%, but our output looks differently. It looks different here. So let's see what happened. Assertion, hello world is not equal to hello world. Well, it's like, ooh, like they look the same. Why aren't they the same? And then if you look down here, you can see kind of the things that are different in between them. The thing that I'm missing is just this. Is a comma. So we know that strings are a list of characters. Those characters do matter. Everything inside of those parentheses does in fact matter. So hello world without the comma and hello world with the comma are in fact completely different strings. So let's go ahead and make sure we do it right. We go back and we say, all right, we missed the comma. We'll save it. We'll try to run it again. And look at that. Red means bad, green means good, and it looks like we have 100% success rate. One passed, it passed really fast. So our code works. We were able to successfully complete our first exorcism problem. And then so after you would do that, you would clap your hands, pat yourself on the back, say, great, I did a great job. And you would submit it after that. And I'll show you how to submit it in a second. But this is the entirety of our hello world function. And again, we wrote a function that returns the string hello world, and that's what we wanted to do. And let's go ahead and let's submit our solution. The way that you submit your solution is you use that Exorcism command line tool, the same one that we used to download this stuff, and you do Exorcism. I think you just do a -s. Or it's either Exorcism -s or submit. I think either one works. And then you tell it the name of the file that you want to submit. The name of the file that you want to submit is just the file that you worked on. You don't want to submit the test. You want to just submit the file that you worked on. So hello world.py. I'll hit enter. And it lets you know that your solution has been submitted successfully. You can complete the exercise and unlock the next core exercise and it lets you know where to go. So let's click on it. And it takes us here. And then we can now see that our code is here. And this is great. So our code's here. And it's sitting here and it's waiting for, if I complete the exercise, it'll basically submit it to the mentors and say, all right, this bit of code is ready to be reviewed. And then someone can come review it for you. This shows you just the test suite so you can actually see what you were writing your stuff against. And then after we complete it, let's go ahead and complete it. It says, well done. You can choose whether or not to publish your solution or not. And if you do publish it, you can allow other people to comment on it, give you feedback, say good job, whatever. So we'll allow that. It's fine. And then it lets us know what we unlock. So makes you feel good a little bit. You know, you finish a problem, you get more problems. It's that gratification there. So we unlock Twofer here. So we could continue. That doesn't mean we have to go into that one, but we went ahead and we completed it. It lets us know what's next. And this is one of the pieces I like the most. After you submit and you complete, you can view community solutions. Again, this doesn't check your code, so it can be broken. You don't have to wait till you finish to submit it, and then you can just view community solutions and you can check, you know, other people and how they did it. And yeah, I mean, for this one, pretty much everyone's going to do the same thing. For the Hello World ones, not really, can't really do that much different here. You could maybe you could set it to a variable and then return the variable instead or something. But yeah, there's not really many other ways to go ahead and do that. So, but you can see how other people did it and you can comment on it, which is very nice. So let's go ahead and let's check out our next. What do we unlock? We unlock Toofer. So let's run through it. So track progression. We finished one item and we already finished 6%, which feels of the core exercises. Okay, I was like, there were over 100 problems. I don't know why we've only done. I don't know why we were 6% of the way through, but we are. Open up the pamplemousse. Pamplemousse. It's not bad. It's definitely not bad. It's better than the berry. It might be better than the lime too. I don't love the lime. It just goes well after the lemon. And it's not bad. We might have a new one that we can pair. I might pair it with the lemon and see if that's the ultimate collaboration there. The passion fruit was good too. So we'll see. All right. So we've unlocked the new one, which is great. We got a little bit of track progression here. So it feels like we're doing something, which is great. And then we have our stuff in the queue waiting for a mentor to come out and check it out. So let's go ahead and let's just keep moving. Let's run through these. I think we did this one together already, but we have to get through it to get past it. So let's go ahead and do it again for anyone who missed it. So what do we want to do with this problem? This problem is Toofer. It's called Toofer. Toofer or Twofer is short for 2 for 1. One for you and one for me. Given a name, return a string with a message. 1 for X, 1 for me. All right. Given a name. So when you say something like that, when something is given to you, that makes it sound like there's going to be some input. That sounds like we're going to receive some data. And remember, we just learned that functions can receive data. It can be passed in. So it looks like we're going to get a name. And if we're given a name, we return a string with the message 1 for X, 1 for me, where X is the given name. So the given name is what's passed in. And we're going to basically put the name where the X is. However, if the name is missing, return the string. So it sounds like if the name is not passed in, that we're going to go ahead and return the string. That might present some challenges. So we're about to hop into that. But yeah, and it gives you some examples so that you kind of understand what to do. If the name string to return. Oh, there's a columns. Never mind. I was dumb. So there's a column of names. So when it's Alice, the thing that should be returned is 1 for Alice, 1 for me. When the name is Bob, it says 1 for Bob, 1 for me. And if the name is empty, it says 1 for you, 1 for me. All right. And now it just talks about exceptions again, just like the last one. And it talks about how to run the tests. Let's go ahead and let's grab this one. How do we grab it? We click the download button, copy there. And we'll go down here and we'll paste. Let me close this one, save this one and close it because we already completed it. All right, so we downloaded it. Let us know where it downloaded to, which is the same folder that we're in now. I just went back one and I'm gonna go into Twofer and let's take a look at these things. I'm gonna Vim this time. I'll go back and forth. We'll alternate. All right, why did it open up on that side? Interesting. So all right, so we know what to do already. I'm gonna close that. Let's take a look at both this file, the file that they set up for us, and the test file. So this is toofer.py. This is the file they gave to us. It looks like it already created a function for us. that just does a pass. It looks like it already takes a name. So they've created a function for us. We haven't had to write our own function yet, which is nice. But they gave you some stub code that you can just fill in. And it says it's the function's called Toofer, and it takes a name. And all it does is pass, just like the last one. So let's take a look at our test file to see what they're asking for. All right, remember all the other structure stuff. We're just gonna look down here for the assertion that says equal, and it says when it runs Twofer with nothing passed in, it's gonna say, it should say one for you, one for me. When it runs Twofer with Alice passed in, it should say one for Alice, one for me. When you run Twofer with Bob, it should say one for Bob, one for me. So let's start. I'm going to close this file because I think we understand that. And let's look back at this and let's break it down from the top. Let's solve it from the top. Given a name, return a string with the message one for X, one for me, where X is the given name. So, us writing this is going to solve the entire thing. So let's do that. So we already have a function that takes in a name. So given a name, return the string. It wants a string. Let's make sure we did it right. Let's copy this. So last time we missed out on when we wrote it in manually, we missed out on a comma. Here, let's paste it in. So this is what they want, but they want us to replace X with the name. So it wants to return one for X, one for me, but it wants to be the name. How do we do something like that? We need to interpolate the variables in the string. We need to do some string interpolation. What are some ways we can do that? The way that I like to do it is this, and go ahead and add the F at the front. What's happening? Oh, the server's, there we go. Going slow. Okay. Let's see. I missed the start of the Exorcism talk. Which mode is recommended? Mentored. Yeah, just do mentored for now. Well, if you're just getting in, you won't be able to see the problems that we're doing. So you can scroll to the very bottom of the page if you already select mentored and switch it to practice mode, so that you can follow along with the exact same ones we're working on. But yeah, definitely mentored mode is what I would say do in the beginning. Sure. So it wants us to return the string. This is a string and it's formatted one for X, one for me. And it wanted us to replace X with name. So that is what we have now. So let's save this. And you can run, like, even though we're using these test files, we can run this on our own. We can test this on our own by simply running, the same way we always run a Python file. We can do Python 3 twofer.py, and this will run this code. And obviously it's not going to do anything. It's not going to do anything because all we have here is a function. And what do we know about functions? For them to run, they need to be called. So let's go ahead and run this. We have to call this function, and let's call it with a name. We know we're passing in a name. And so I'll call it with Aaron, and let's see it run. Whoa, didn't run at all. What happened here? Def Toofer. Oh, that was dumb. It did run. It ran. But remember, we didn't print anything. So we need to print we need to print the output of all this and run it. And it looks like it says one for Aaron, one for me. Let's change the, actually, that's fine. Let's change the, oh no. Change the name just so we know that it's doing something properly. Sarah. And we run it. One for Sarah, one for me. So it looks like we did the first part. So let's remove this print line, and let's check what the tests do. We don't need any extra stuff here. Let's run this against the tests now. So let's save it. And what do we do? Pytest. How can we confirm what we're supposed to run? You can look back in this Readme, which it'll be here too. Well, you just run in the test. Just run Pytest Toofer test.py. So we'll do that. And we run it. Look at this. We haven't seen this yet because we haven't seen multiple test cases. First time we're seeing multiple test cases. We get at the top, we get 2 passing cases. Collected 3 items. So there were 3 cases. We went through those 3 cases. It was basically 1 for when it was empty, 1 for when it was Bob, and 1 for when it was like Amy or something. I don't know what the third one was. But it runs through. It only gives us the output for the one that failed. So we can see here at the bottom the 2 passed, that 1 failed, and the one that failed is this one says missing 1 required positional argument name. Now we learned this again. Remember I said this might be a problem. We learned that if you don't have a we learned that you need to pass in exactly how many arguments are set up in the function definition. So if the function definition asks for 1 argument, you need to pass 1 in, or if it asks for 2 or 3, you need to pass in however many are created in the function definition. And again, that function definition is simply where the function is defined using that def keyword here. So we have 1 argument that is here. So those 3 test cases, take a look at those. Let's take a look at those 3 test cases. Let's open up this one. In these test cases, the first one that it tried to do didn't actually pass in any arguments, which can be problematic. But these 2 do. So it looks like these 2 passed, but this one did not because it needs at least 1 argument. Now, what did we learn last time that we could do to make sure that even if you don't pass an argument, that an argument gets a value? What we can do is we can, FG, we can simply give, let's see. We can simply give our name a default value. So we can say this equals you because it says, what just happened? Name equals you. It's supposed to say 1 for you, 1 for me when nothing's passed in. So we can give this a default value. So basically when you give this function a default value, what it will do is if nothing comes in to override it, it will give it this default value. So now that we've given a default value, let's go ahead and let's save it. And let's run our test cases again. And boom, just like that, we have solved our next problem with just a few lines of code. So again, let's take a look at it to make sure we understand what happened. We wanted this to say basically 1 for you, 1 for me, and we wanted to, or 1 for X, 1 for me, where we replaced X with the name that was passed in. We wanted a function that took in a name. And so one of our test cases was without a name being passed in. We need to know how to handle that. It is okay to, there's some other ways to, I've seen people do this where they'll actually change, like they'll remove the name from here, and then they'll do like some weird, like it won't really solve the test, but like the problem will work. But this is how you would do it. Wait, actually, that's not how you would do it. There we go. This is how you would do it. And we can submit it and we can start the process of getting feedback. So how do we submit? Let's practice submitting again. Exorcism, submit, and the name of our file, which is twofer.py. And lets us know that our solution's here, that it made it there. Take a look. It's on up here. And and we can complete it. Oh, maybe not. Maybe we can't complete it because no one's completed because no one's commented on our first one. Okay, interesting. So maybe we'll have to switch out of this mode. It doesn't give us any more. All right, so it didn't open up any more problems. So this is why originally I was saying originally that I was gonna go, what is this other mode called? The other mode, oh, actually, hold on, does it give us any of, okay. Let's scroll to the bottom. Whoa, they changed this up a lot. This is different. How do I switch? I'm gonna switch back to practice mode. So if you scroll down on the side, it might be in the middle if your stuff's not as if you don't have it zoomed in as much as I do. But I'm gonna switch to practice mode so that we can do whichever problems we want. But we're still gonna go in order. We're gonna go in order, or as much as we can. We're gonna go in order. So excellent. So we got 2 done already. Twofer is waiting on a. Oh, actually, I'm gonna cancel this mentoring request. We don't really need it. I'm gonna complete it here. It is important to note that if you do. I said do. If you do the mentored mode that, or the practice mode, that you do get, you do only get a certain amount of mentor requests, I believe. Yeah. However, oh, it's just one at a time. Never mind. So it's not a max anymore. It used to be like you could only get like 6 requests for feedback if you were in practice mode. But it looks like you can get one. You can get unlimited, but one at a time. So view community solutions. Oh, can I show the solutions again? Yeah, this is our solution right here. Yes, take a look at that. Finally to come in. What's up, Mr. Pentakills? Been slam dev boarding a new company. Hope all's well. Hope all's well with you. Congratulations on the new company. Hope you're loving it. What's with the cape? I said in the beginning, we talked about it. I just, right before this, I came from a Hack Baltimore event. Hack Baltimore is a pretty cool civic hacking initiative. And tonight was like the kickoff event. It's gonna be a big event, a big like hackathon in May, I believe. And they gave out capes because we're gonna be the people to put our heads together and make some real change in the city. So I was just part of that cool event. I'm definitely gonna be participating in all the things that they're doing. I'm gonna definitely get a team set up. So if you're in the East Coast, if you're in the Baltimore DC area and you're looking to have some fun solving some cool problems, let me know. I'm definitely gonna create a team for it for sure. But that's why I have on the cape. I'll probably wear it a lot. I'll probably get one that's blue though. But I like the whole cape theme. Let's see. Assigning default value that way is slick. Yeah. This is really nice. And you know what's funny is I think that the first time I had to solve a problem like this, I didn't know you could do a default value, and I had a lot of trouble. And I was like, man, this is like one of the easy problems. It says it's an easy problem, but I was struggling with it. Don't sweat that. I know that they label them. I actually hate that they label them as easy or like hard. Like if I go back to the Python track, it says like these are easy, and yes, they are. But I feel like they're only easy in comparison to harder problems. It's all relative. So I don't know. I don't really like these designations. I would more so try to pick some denomination of ordering, just like, hey, this is just problem number 2. It's not easy. Like we do think that they range in difficulty from easiest to hardest, but like these aren't the easy problems. Because I do think some of these easy problems are a bit tough. We're actually going to skip raindrops. I think we did raindrops, but we've definitely done FizzBuzz, and it's very FizzBuzzy. So we're going to skip raindrops. Let's go to high scores. I don't know what this one is, but it's going to be fun, I think. All right. It looks like we have a little bit more to read this time, maybe. So the goal here, we want to manage a game player's high score list. This is great. Now, I actually really like this because now it feels like we're doing something that you wouldn't like, that someone would be needing in the real world. This sounds like something you might be writing code to do. So we need to manage a high score list. Your task is to build a high score component of the classic Frogger game. All right, so they're putting in the context for us. So the classic Frogger, you got to jump across the road, make sure you don't get hit by the cars. So it's one of the highest selling and addictive games of all time. And the classic of the arcade era, that is extra information. It sounds like it's there designed to throw you off, or just to tell you that Frogger's a thing, because I guess it would make sense that people wouldn't know what Frogger is, because I haven't seen anything about Frogger in years. Your task is to write methods that return the highest score from the list. I wonder if they really want us to write methods or not. The last added score. Okay, so return the highest score from the list. So we need the highest score. We need the last added score and the 3 highest scores. Okay, all right. We'll take a stab at it. I don't know what that means yet. In this exercise, you're going to use and manipulate lists. So now we're going to use some lists in our code. Python lists are very versatile, and you'll find them. You'll find yourself using them again and again. Cool. So it sounds like they want you to get some list exercise here. And then they give you some links to learn about some of the topics that we're going to be covering in this. So if you didn't know about lists, you could take a look here and you could learn a little bit more about lists and how to manipulate them, lists and tuples in Python, and Python lists. Just a few different resources here for you to get some information about the thing that you're about to be working on, so that you can try to solve it. So you don't need to be able to go in and solve these things in a few minutes. Take as long as you need to pick up the concepts and fight through it. Like for as long as you can. I mean, if you're completely stuck for a really long time, like don't waste your time. Like this is not life or death here. Like go find the answer or submit it and find out what you were doing wrong or find out what you were missing. But yeah, let's copy it, let's download it, and let's get started on it. Paste this in. It's going to download it to this directory. But again, I know it's one back. And now we have iScores here. CD. iScores. Okay. We have our files here. And let's go back. We'll use VS Code for this. And we'll bring up our README just so we have it. And I want to see the cool version. We will bring up our the file, and we will bring up the test. So now our test files are getting a little bigger. We're getting a lot more stuff. And take a look at this. Like this time we actually have 3 different functions that are already stubbed out for us. So the type of code we're doing is a little bit bigger now. And it can be overwhelming. It can be overwhelming when you get in here and you're like, I just got to working with a single function and now you're giving me 3. I'm not sure what to do. Don't sweat it. Let's break it down. All right. Task is to build a high score component of the classic Frogger game. So we need to write methods that return the highest score from the list. So we already know we're going to be using a list. They told us we're going to be using a list. So we need to take the highest score. We need to be able to find the highest score. We need to be able to find the score that was last added. So the latest score. And we need something to take the 3 highest scores. This is interesting. Interesting problem. All right. That's interesting. So let's take a look at what they gave us. So it looks like they gave us functions to do exactly that. So the latest score. So that's the most recent score that was added. Personal best sounds like it's the highest score period that they want here. And personal top 3 scores sound like it's the 3 highest scores that we want to do here. So I'm already just thinking of a few ways we could do this. But let's start from the top. Let's start from the top. Actually, let's take a look at our tests and see what we have here. So here looks like we have the scores that are going to be passed in. So we know latest scores. They pulled a different paradigm here. For the output that they're expecting things to be, they're setting it equal to a variable. So it's the same as before, even though it looks different. It's just a cleaner way of doing things so that you didn't have to put a bunch of numbers here and a bunch of numbers here. So it's basically saying when they pass in latest, they're gonna check the latest function. We know that we have a latest function here, so it's gonna run this function, and with this, it's gonna be passing in scores. and scores is set up right here. So it's gonna pass in a list of scores, and we have a list of scores here, 100, 0, 90, 30. And then when it passes it into there, it should return 30. Our tests are expecting that it will return the number 30. Why is it expected to return the number 30? Because number 30 is the last item on the list. And right here, we're looking for the score that was added last. It was the latest score. We know that lists are ordered, they're positional. So the latest score would, if you were appending things to this list, would go in the last spot. So this is great. We have something that checks for latest. And we have a bunch of stuff here that they all check different functions: personal top 3 scores, personal best, and there's a bunch of cases here. There's more than just 2 or 3 cases. There's a bunch of different cases, and having these test cases, having all these different options, should help us be, again, confident that our code is running the way it's supposed to run. So let's try to write something to return the latest score. Let's copy and paste in just a list from what it's going to check. We'll copy and paste this just so we can have something to reference here. So we'll put it down all the way down here just so we can see. So it's going to pass in a list of numbers, a list of scores, and we need the latest score. So this last one here. When you first start writing it, you may look at that and you say, we know we need to return something. And so we're going to return the latest score. We can see in this problem, if we were just looking at this thing that they gave us, we could say, all right, go ahead and return there's 4 items here. We know the 4th item is going to be the last one. We can say, all right, I know this is indexed as 0. So 0, 1, 2, 3, go ahead and return scores, or what, because that's going to be the list that's passed in. Go ahead and return scores 3. And this will work. Like, this will actually pass our tests. It's going to return the thing that is in the 3rd index spot, which is the 4th item. So this is the 0 spot, 1 spot, 2 spot, 3 spot. And so let's run this code. And you'll see when we run this code that this test is actually going to pass. Test scores. All right, see, we have 1 pass test. All the rest fail, but we have a pass test. The problem is, what if this, our problem never states how many things are going to be passed in. It just says it's going to take a list. What happens if we pass in even just 1 additional number? What happens if we put we can test it here. We can actually modify the test to change too. Like, what if we pass in, another number like 67? What's up, Hester __? Welcome. Thank you for the follow. Welcome to the channel. What if we have an extra item here? What's going to happen now with our test? Let's go ahead and try to run that again. Terminal. Hold on. Control Shift tilde. What is tilde? Sorry. Let me just figure out what tilde is on my keyboard. Escape. Shift. Okay. Got it. So it's so it's 2 shifts. How do I do this? Modifier. Nope, I don't know how to do it. I can't do it with this 60% keyboard. Can't figure out the thing to just open up my terminal here. All right, so let's run this now. Pytest. Scores. Now nothing passes. Why does nothing pass? Nothing passes because we're telling it, we're being very explicit, and we're saying go ahead and return whatever's in the 4th spot. But now our test no longer has 4 things has 4 things in it. It has 5 things in it. So we can't do that. And that is kind of how this is an oversimplified version of kind of how people start to write to tests in the beginning. You'll get some tests, you'll write to the test, and you'll do exactly that, and it does work in this case. But that's why you have to write multiple test cases to cover your bases and make sure you are doing things properly. So yeah. So how do we return the latest? We learned that to go You can do a couple things. You can do two things. You can do scores. We know how to check how many items are in a list. How do we check how many items are in a list? We go ahead and, whoa, this is not what I thought it was. We can go ahead and we can check the length. And if we check the length, it'll tell us, whoa, got some feedback. Whoops, sorry about that. Cool. We can check the length. So the way we check length is length like this of scores. And so if we check the length of scores, well, we're not going to return the length of scores, but this is just how you would check the length of scores. If we check the length of scores, what would it be? It would be 1, 2, 3, 4. There are 4 items in here. The length would be 4. But the only way to return, one of these items is to use this index. So we could do this. We could use that as the index number. So we could say scores. And then in parentheses, because length will return a number, and maybe I'll expand it a little bit to help you understand what's happening here. But we can check length of scores, and let's run this really quick. What's up, ZZ29093? Welcome to the channel. Thank you for the follow. Pytest _ And if we run it, nothing passes. And let's take a look back up at the first item to see what the error is. So remember, it gives you some output when things fail. And it says list index out of range. Why is it out of range? It is out of range because what is the length of scores? The length of scores is 4. So if this number is 4 right here, this number becomes 4. If you check the 4th index item, there is no 4th index item here. There's only 0, 1, 2, and 3. So it's out of range here. So you got to do length -1. This is something you're going to have to do often. Off by 1 errors are very, very common. And if we run this again, we now see one thing passes, and that is this. So you could do this. And again, we can break that up a little bit, just to make it a little more clear about what's happening. We know that we can call an item in a list by its index. And so you could maybe say index equals length of scores -1. So this is going to give us a number. This will give us a number, and then we can put index in here if you wanted. I don't know if that's easier to understand or not. But this is a number. We're basically just calculating an index number here and referring to the list, that list index here. So that's one way you can do it. But the easier way, I think we've talked about this before when dealing with lists, with traversing lists, etc., is you can just do a -1. This is the easiest and the fastest way. What's up, Fire? Thank you for the subscription, the tier 1 subscription, not even an Amazon Prime. I appreciate that. Really, really appreciate that. Dope that you've been watching. I appreciate the kind words. I really appreciate it. Welcome, welcome, welcome. So you can use a -1. A -1 will allow you to basically go backwards through the list. It'll only allow you to go through once, I believe, but yeah, a -1 will work as well. And so we can new terminal, man. I really got to get my workflow down with VS Code. You guys can easily see that I'm really struggling with VS Code. Scores. But it's just because it's not a good thing. It's a great thing. So 1 pass. So it looks like we're passing that test now. We'll leave it at -1 because -1 it's the preferred way to always grab the last item on the list. It is the same thing as length -1 here. So, all right, so that's how we get the latest score. That's how we get the last score on the list. Great. Not crazy difficult, but it teaches you a few items. Like even just this option, if you were completely fresh to this, or you hadn't been watching and you hadn't picked up that, hey, you don't know anything about indexing, like indexes and lists and things like that, you would have learned a lot by trying to solve this. Like, yeah, I know I need to choose the last option in the list, but like, how do I know, the list could be 100 items. How do I know how to choose the last item? And that is using the -1 index or to use the length -1 index there. So Take a break. We've figured out how to do one piece. We've got one test passing, and it looks like that's the only test in here that's using latest. So we can do a search for latest, and it looks like it's in here one time. So this is the only test that's using this. So we've solved that test case for now, or we can be relatively confident that we solved that test case for now. All right. What's up, Evil Pisces? Thank you. I appreciate that. It's really encouraging. Really, really encouraging. Cool. Latest. This is very interesting. I'm always surprised at how they changed the things that you're working on. So they've always had some variation of something like this. Like we went through when I first started streaming on here, we went through we were doing something called the Crucible, and we were kind of just running through these, and they've changed a lot since then. They've added more depth to, it looks like all of them, to be honest, which is really nice. I really like it, because when you go to interviews and stuff, if you're trying to be a software developer, web developer, if you're gonna be writing code, some places, not all places, they'll give you either a take home or your whiteboard something like a word problem like this. They just, like, some of these just have extra words in here. Like, they didn't need to tell us anything about Frogger. I'm not sure why they did that, but I like it. I like that because it can throw you off, and just learning how to break those things down and is really great. Okay. Let's head to the second thing that we need to do. We need to figure out the personal best. So now we need to figure out the highest score. I like this one. I really, really like this one because there are a bunch of different ways to do this. There are a bunch of different ways to do this. This is where something like one of those sorting algorithms can come in place. So you're going to get passed in a list of numbers. You get passed in a list of numbers. Some of them have a lot in here. Some of them just has 3, some of them have a bunch. But how do you figure out what the highest number is on the list? And this can be tough. Like, I think this is our first real, like, dilemma of like, I don't think we've been taught any of the tools yet to do this. So, the first thing is you could sort this list. The list needs to be sorted. The list needs to be sorted for you to be able to do anything with it. So ideally, you would want to make this either from high to low or low to high, or you just need to move the highest number to a place where you could know where to grab it from inside of this list. So Python does have a sort feature, and I'll show it to you. So this is why Python's nice. This is another reason why Python's nice. It has some cool built-in tools like this, but Python has 2 sorting features, actually. So Python has a sort method. So you can, if you do it on like strings, it'll do it alphabetically by default. For numbers, it will do it, for numbers that are passed in, it should do it from low to high, I believe. So you basically have a list here, and then you do a list.sort, and that will now make the list a new thing, I believe. One of them makes a new list, and one of them you have to. Okay, yeah, this fixes the list in place. So let's try this real quick, and let's try this inside of the. Let's try this inside of the interpreter. Why did this happen? And so, what's up, solo developer? Welcome to the channel. Thank you for the follow. So let's make a list here. List just called X. And what are we gonna do? So let's do 4, 6, 1, 9. All right. So if we do x.sort and we hit enter and we do print X, look at that. Python has done all of the hard work for us. Which is really nice. It gives us a list that is already sorted from high to low. I think you can pass in like a reverse. I think I saw that in there to make it go from like low to high or whatever. I mean, or high to low. But yeah, you got some options in here. Reverse true, so you can pass in true into here. So let's do that actually. Reverse equals true. Is that what we want? Is that what we want? So let's reset X, and then let's do sort. I've never used this reverse equals true. That's pretty cool. Reverse equals true. And if we print X again, it's from high to low. Super nice. That's really cool. Again, for words, for strings, it will do it alphabetically. So that's nice. But yeah, you already have this sort here. So there's this sort and there's another sort. There's another way to sort in Python. Python sort. I forgot what it is. Sorted. They're sorted. And so sorted works a little bit differently. Sorted, you have to assign to, well, maybe not. Numbers, sorted, numbers. Oh. Okay, same thing. Number sorted equals, oh yeah, I think you have to assign sorted numbers back to, I don't think sorted modifies the original. It's not a method on top of it. It's a function. I think you have to reassign it. Oh yeah. You have to reassign it to another variable. So like you can't just do, like if I reset this again, so it's an unsorted list again. If I run sorted X, it will display the list sorted. It'll display it sorted, but if I print X, it doesn't modify the original list. So this list dot sort method will modify. It'll sort and modify the list. If I use this sorted function, it will do it, but it will not modify the existing list. So you have to save that value somewhere else. So there are options to do that yourself, but I think it'll be fun to do this ourselves. Let's sort this list really quick ourselves. What you can do, yeah, let's do some quick sorting real quick. Let's do like a bubble sort on this. So how do you sort a list? No, actually it's exciting. Let's actually just do a list sort in its own file real quick. So let's grab something like this real quick, just so we have some numbers already. And I'll show you how to sort some numbers manually. Just know that you have these, use these. Like you should be using sort or sorted, depending on your needs. Makes it a lot easier. But we're trying to learn how to solve problems, trying to learn how to solve algorithms, how to think programmatically. So let's go ahead and sort something ourselves. So I'm gonna vim sort.py. Let's go ahead and do a quick sort here. So we're gonna do a list. Our list is gonna be called, I'm gonna call it our list. It's gonna be called, it's not gonna be called, it's gonna have these numbers in it. What's up? Oh yeah, thank you for the follow already. I'm glad to find this stream. I think it's awesome you're doing. Python seems strange and informative to me coming from experience in C++. Yeah, that's awesome. Yes, if you're coming from a language like C or C++, Python will absolutely seem strange and very informal. I lean towards probably the things that you like. Like my language of choice right now is Golang, and I find that Python is very informal in comparison, but it's still fun. It is fun for sure. And it's so easy to get into, like to just hop in and do something cool with it. Yeah. So we have a list here. We have a list here, and we need to sort this. So it's all out of whack. So let's go ahead and sort this. How would we sort this? And there are a lot of infographics out here to help you visualize. I do think that they help visualize how you want to sort something. But the way that we're going to sort something right now, is we're gonna take what we know, and we're going to use some of the operators and things that we already know. So we're basically going to take a number, and we're going to compare it to the number next to it. And basically we're going to take 10, compare it to 30. And we're gonna say, hey, is 10 bigger than 30? Because if it is, we need to go ahead and swap these numbers. So it'll check this. It'll say, nope, no big deal. So let's go ahead and let's move on. And it'll run through. It'll say, it's 30 bigger than 90. Nope. So that looks like it's right. But then it'll get here and it'll say, is 90 bigger than 30? And then it'll say, yes, 90 is bigger than 30. So we need to swap those two things. So what we'll have to do is we will have to make sure we change these places. So remember that these are indexed. So we'll have to make sure position number 2, so 0, 1, 2. We'll make sure 2 becomes 3 and the 3 becomes 2. And then you keep going down that line and you have to do it with everything to get everything sorted. This is one method of sorting. There are other methods of sorting. Other methods of sorting, like merge sorts, where you basically split some things in half and then you compare so basically you would have two separate lists here. So we would basically cut it off here and have these are being a list and these would be in a separate list. And we compare the first items in each of those lists and push things in accordingly. And we basically merge these lists together, split them apart, merge them together, split them apart, merge them together until we have a list that is sorted. But there's a lot of ways to do stuff like this, but we're going to go ahead and do our first iteration of this and sorting this. So what do we learn if we want to perform an action over and over again against an item that we can iterate over? Well, what can we use? We can use loops, specifically a for loop, because I said we want to iterate over an item. We want to iterate over this list. So what we want to do is we want to write a for loop. And I'm going to say for number in our list. All right, so for number in our list, let's just start with this. Let's just so you can see what's happening here. For number in our list, we're gonna go ahead and print the number. Just so you can see what's happening, that a for loop is gonna run through each item in this list, and it's gonna go ahead and it's gonna print out that number for us. So let's Python 3 sort.py. All right, so we get it spit out. We got numbers in our list now. Because we are, yes, we could do this, which is great, but we could do this, actually. But we could also because we want to use some iteration, we can use the range function and the length function to determine how long this list is. So you don't need to do this. But you could if you wanted to do it from back to front. I've seen this done in a bunch of different ways. But we know how many things we want to iterate over, or we can find out how many things we want to iterate over. But actually, we're going to leave this off. We're going to make this as simple as possible, actually. So for num in range, we want to compare, let's say we want to compare number. Oops. We don't need range. Our list. For everything in our list, like we want to compare the things to each other. If we just iterate over everything in here, it's going to be hard to compare one thing to the next thing and to kind of figure out how to go back and forth. So what we actually want to do is we want to be able to use these indices. So we are going to put in the range here. We're going to say range, the length of our list. So we want to see how long our list is. And what range does, remember, we used range to count to 100 before. Range basically goes from 0 to whatever number you pick, or from whatever numbers you put in there. So I could put 0 to 100. I could put 0 to the length of our list. I could put, if you don't put in anything, by default, it starts from 0. So basically, it's going to say for the amount of items basically in our list, go ahead and run this loop. And so the first thing we're going to do is we are going to compare items. So we're going to say if num, so when it runs the first time, because we did for I in this list, it will choose, it'll say, all right, 10 is the first item, and we're going to use that here. So we're going to say if num is greater than num, and then we can use some index here. We can use an indice here. Actually, this is not going to work. I need to be able to select the indice. I'm going to say num. How can we use this? No, this does work. I have to call our list. So number is actually going to be a number. It's going to be an indice. So when it gets here, it's going to be 0. When it gets here, it's going to be 1. When it gets here, it's going to be 2. Here, it's going to be 3. So our list at 0 is going to be 10. Our list at 1 is going to be 30. Our list at 2 is going to be 90. So I'm gonna check if our list at num is greater than our list at num plus 1. So basically going to say wherever you are in this list, take the number that you're at and compare it to the number after it. And if it is bigger, if the first number is bigger, go ahead and do something. So the first thing I'm going to do is, just so we can see if it's working, we're going to print out, let's go ahead and print something out, and we're going to say, let's do a formatted print. Let's say num, let's say our list, num, our list num should be swapped with our list num should be swapped with our list num plus 1. I think this will work in here. Maybe, I don't know if it'll format these or not. So I basically just wanted to tell me when numbers need to be swapped for the first iteration of this. It's not going to swap them, but it's going to let us know. So it should basically show us this. It'll show it here, but then this will go here. So it's 90 bigger than 100? Nope. Is 100 bigger than 20? Yep. So then it'll need to swap here. It'll need to swap a couple times. So let's see how many times we get when we run it. In the file while parsing, I forgot something, which is I forgot to close the print statement. All right, so it looks like we said 90 should be swapped with 30, 100 should be swapped with 20, 20 should be swapped with 10, 10 should be swapped with 0. All that makes sense because these first numbers are bigger than these second numbers. And then we got an out of range. So let's figure out why we got an out of range. Again, off by 1 errors are pretty common. And so basically we needed to do this -1. Whenever you get that, it's almost always a -1 after that. I am, Lieutenant Hummus, I am writing a bubble sort right now. We don't need to write a bubble sort here. Just kind of a topic that we're going over. We've already discovered the sort function and the sort method, the sorted function and the sort method, but we're just learning how to do it ourselves really quick. But yeah, we are doing a bubble sort. So now we can see how many things need to be sorted. So let's go ahead and actually sort it now. So instead of printing, let's go ahead and let's actually do the sorting. So some caveats here. Well, not some caveats. Let's just do this. So if this is the case, we know that they need to be swapped. So these are already positional arguments, basically. So to swap them, you can do this in 3 different ways. But starting out, people usually do something like this, and I like to go over the things when I say starting out, I like to go over the things that I've seen people do when they go over this, like when they go over this stuff for the first time, because logically this make sense first, and you would say, cool, that just means that our list at the num spot, our list at num is now equal to our list at num plus 1. So you say something like that, and then you go to the next line and you would say, also, I changed the value of that number, and I can change the value of this other number of num plus 1 is now equal to the value of our list num. So what does this mean? So you can change the value of any of these items here in this list. And let's look back at our, let's log into the Python command line here, I can change the value of 1 by specifying its place. So I can say X, 1 is at the third spot, so 0, 1, and 2. So I can say X at the second index is now equal to 600. And when I print X, this is now 600. So now when we look back at the code that we're doing, so take a look at that really quick, we can specify the list and the index that we want to change, and then we can tell it what value it's equal to, and it will change that value. In our code, like if we want to swap them, we can basically say, all right, well, our list at this index value is now equal to our list at this other value. So that makes sense. It does make sense. And it's like, all right, cool. Then I'll just now assign the other value. I'll say our list at +1 is now equal to our list at num. And so it appears that it'll swap the value, but this will not work. And I'll run this. I'll run it just so we can see it, but it will not work. But let's see what happens. At the end of this, we are going to print our list and see what we get here. All right, so Python 3 sort.py, and we run it and we get 10. Actually, let's print out the original list so you can see the original list every time we run it. So we're gonna print. All right, so this is the original list right here. And this is the list that we have now. And you can see here, this is like missing some numbers. And it's got some duplicates. 10, 30, 30, 30, 20, 10, 0, 0, 30, 40, 40, 70, 70. Where are we getting these numbers that we did not get before? And where's the 100? And where's the 100? The problem is, if you do it like this, and again, I only bring this up because I see this all the time when people are first learning bubble sorts. And it is because when you do this line right here, you have now replaced the number that it's comparing against. So you basically, like when you get to here, it says, all right, go ahead and swap these. So you say our list num is now equal to our list num +1. So what it does here is it takes 90, this spot that's at 90, and it sets it to 30 because it's swapping it with this. So it puts 30 over here. But now when it runs the second line, and it says this spot is now equal to this spot, it's just setting it back to itself. So you can't change one and then change the other. They need to be done in tandem, or you need to do it kind of outside of this. You need to track the values outside of this. So this can be done in two different ways. You can do it in two different ways. You can do something like this. You can say something like lower num, and you can say something like upper num, so you could track it outside of this. Lower num and upper num, so you can say the lower num is the one that is second, and the higher num is obviously the one that's first because of the way that we're checking. And then we could say, now we could use those numbers that we're tracking to say our list at num is actually, we want it to be the opposite, right? We want it to be the opposite up here. We want the lower num to be the first number. Wait. What are we checking for? Our list num is greater than, oh yeah, so no, this was right. Right? No. Why's my brain broken? Okay, we're checking for the number that is lower. We're checking this. If this is higher, swap it. So yeah, so we want the lower number. It's going to end up being the second number. So this is right. And then, so we basically track those values. So basically, once we get here, it'll basically say, all right, the lower number is actually 30. It'll set it to lower number, and the higher number, maybe I should change it to higher instead of upper, is actually 90. So these two values we can set to 30 and set to 90. And then we will just replace these spaces with those numbers. So our list is now lower num. And now this one is R list num plus 1 is now equal to upper num. And so basically we're tracking values outside of the list, and then we're replacing them in the list. So if I do it now, I do get a different list. I get a different list. It's not sorted. We'll talk about why it's not sorted in a second. But it doesn't remove any values. My 100 is still here. It moves some stuff around. It gets things closer to being sorted, but not all the way sorted. Let's figure out why it's not sorting. Actually, I'm gonna delete this just because there's a lot of lines. There's also an even easier way to doing this. You can assign the value of two variables in the same line. So the way that we can assign this very, very quickly in one line is to swap it is we can say now, our list num. And if you separate it by comma, you can tell the other name of the variable that you want to change. So we're gonna say our list num plus 1. And then you set those equal to, so you have a first item and a second item. And then so you need to keep the respect here, and you need to give the value that it's supposed to be. So now we say our list num plus 1 and our list num. All right, so this can be confusing, but look at the mapping. Before the comma is, we're setting our list equal to our list num plus 1, our list num equal to our list num plus 1. And in the same go, we're changing our list num plus 1 to our list, and they're separated by a comma here. So you can do it in a one-liner. Again, it may be easier to understand what we're doing here if you saw something like, you could do something like X comma Y. This is not in regards to this problem, but if you wanted to set two variables, you could say one was 20 and you could say one was 40, and it would set X to 20 and Y to 40. And that is exactly what we're doing right now. It's exactly what we're doing in this problem right now. It's just a lot of text because of what we're doing. So we run it again, we get the same output that we got before, but the list is not sorted. Why isn't it sorted? It's not sorted because we've run through this list. We ran straight down the line and we made the comparisons, and we did sort them properly. We did do the actions that we wanted to do. The problem is when you move something over one place, that doesn't mean it's in the proper place now. It just means that in the context of our one run through, that everything is looking good. So now we need to make sure that it goes through everything until it's done. So there are some ways to make this more efficient. There are some ways to make it not run a bunch of times. But the way that we're going to do that is simply to, not only do we have to iterate over the entire list once, we have to iterate again. So we have to do a nested loop here, and we do the exact same thing. There are a couple different ideas about this. I've seen this done in different ways, but this is by default. I think this is the easiest way to understand, is to basically say for everything in this list, and then again for everything in this list, and we'll walk through everything. But run this. So go down. We'll put this over. All right, and first I'm going to run it. I'm going to show you that it sorts. You can see here the list now is 0, 10, 10, 20, 30, 30, 30, 40, 40, 40, 70, 70, 70. 70, 70, 90, 100. So it sorts. But why does it sort? Why does it sort? Why does this nested loop now make it sort? This is where nested loops again get crusty, get confusing. So it runs this for loop. All right. It starts the for loop. It says for each item in here, do whatever's below it. So when it gets to a second for loop that does the same thing, what it's going to do is, when there's two for loops like this for loop will run once for everything here. But so it gets into 10, and then it does it again. It says it again. So it's already at 10. And then it starts again. It says, all right, but also for everything in this list, run this. So it's going to run it. It's going to compare them. It's going to compare this to this. It's going to move it if it needs to. And then it's going to keep going. It's going to compare this number to every number basically throughout the whole list before going around to the top loop again and going to the next number. So it'll go through here, it'll compare this to everything down here, and then it'll sort stuff out, and then it'll go back up here, and then it'll go to the next number and do the same thing, and it'll go down and do the next number, do the same thing, and go down and do the next number, same thing. This is not the most efficient way to do it. It runs fast because computers are fast now. If we were to check this out, if we were to like actually look at how it was sorting, it will be done sorting before it finished running. It probably sorts pretty early, actually. It probably sorts pretty early, and maybe we could put that would be confusing. I was like, I could put a print statement in there. We don't need to do that. We can keep running through what we're doing. But it's just a nested loop. It's basically running an action against everything in the list, and then going to the next item, and then running against everything in the list. And so this is how you would do a bubble sort. They call it a bubble sort because you kind of move the bubble along down the line. So basically what was happening is we're taking this 10, and this 10 gets moved one spot at a time. It gets compared, it gets moved all the way down the line, basically to all the way to here, and then the next number gets moved all the way down to where it's supposed to be, and down to where it's supposed to be, or opposite because it's the lowest number. But like a 30 will get moved over some, and the 90 will get moved over. Everything gets bubbled over to the right or to the left, depending on which way you're attacking it from. Again, this is why I didn't want to spend tons of time on teaching these algorithms or teaching these types of algorithms, because yes, they are good to know. I think they're powerful, and like understanding the logic of how some of the things work is great. But also, we simply can just use that sort function that we learned. So we can save ourselves tons of time. But it is good to know kind of how these things work. So we can do that. So let's go through this. Remember, what we were trying to do is we were trying to find the personal best score. So we're trying to find the highest score in the list. So the first thing we can do is start by sorting that list. So if we do scores.sort, it'll give us a sorted list from lowest to highest of scores. And then if we do that, if we do this, if we have a sorted list, we know that if the highest number is to the right, we just learned how to return the number in the list that's all the way to the right. So we can return scores -1. So it'll basically it'll modify the list for us, put it low to high. We know the highest numbers are going to be all the way to the right, the last item in the list, so we can grab it again with a -1. So pretty simple here. But again, if you're doing it manually, you can stick that whole sort function in here, or you can write a sort function down here and call the sort function. You can do that. Maybe we'll do that. Maybe we'll copy and paste in and check that out in a second, and see if that's something that we just see work. But we can just simply use this sort here to sort it and grab the score. So let's go ahead and let's save it. Let's run it. Let's run our test and see if we have solved more of the test cases. And we run it again, and we see that now we have 2 test cases that are passing. And it looks like all of these are for the third function. So we don't see any here that are for the function top score or personal best. We see them all for personal top 3 scores. So we've solved 2 of them now. And so all these are for the last one. So now let's figure out the top 3. How do we do that? How do we get the top 3 highest scores? That seems a lot harder. But it's not a lot harder. What's up, man?
What's up, bro?
Your boy Terrence is here.
Hey, folks. How y'all doing?
But yeah, how do we get the top 3 scores? It seems a lot different. It's not a lot different. So think about it. We just learned how to move the scores around and get them from the lowest score to the highest score using the sort function. Sort function will do that for us. And so now we know that the highest 3 scores have to be at the end of the list. They have to be all the way at the right at the end of the list. And so how can we grab those? So let's go ahead and let's sort it again. So we need to do we need to have a scores.sort here. Why do we need to have it in both functions? Because these are completely isolated pieces of code. And you won't be able to grab this. We could do it in a way where we could grab this, but we won't have access to it. So we need to run this sort. And this function might not ever get run before this function. So we have to do it like this. So we'll sort them. And then we can only return one thing. So we only return one line. So you could do something like this. You could return multiple items in that one line. So you could return like score 1, comma, score 2, and score 3 if you wanted to do that. But how would you get those? So you could do like score -1, which will be the highest score. Score -2, because remember, it's going to grab -1 is going to grab the last item in the list. -2 is going to grab the second item, second to last. Score 3 is going to do the third to last. So you may be able to do something like this. That's not wrong. It might be wrong for these tests, but not really wrong. And let's see what happens. Let's see what happens if we do that. Let's see what happens if we do that. I like this. Terminal, new terminal. Okay, still fails. Makes sense. What is it? I wonder what it's returning though. What is it getting back? Same score is not defined. Oh, whoops, scores. Let's see it when it's real. I misspelled it. It needs to be scores and not score. I just want to see what it's returning. Well, I know what it's returning. I want you to see what it's returning. All right. It's giving us, look at this. Index. So we got an index out of range for the first one. Okay, cool. We'll check what that means. We'll check why that is in a second. But this one here, we get 40, 40, and 30, which is not equal to 40, 40, and 30. So we're basically returning a tuple here, a tuple. But here it's supposed to be a list. But we are getting the right number, so that's cool. Let's check the other one and see if this one doesn't even, when there's only one. All right, so there's one item. It passed in 40, expected 40. Okay, that, oh, got an index out of range here. All right, I'm tripping. Got an index out of range. So cool. So we can't do it that way. We didn't pass any test that way. And it needs to be it looks like it needs to be a string. I mean, a list that we're passing back. So how can we do this? What did we learn about lists? Lists can be in lists. What do we learn about list indexes? So we learned about the -1 here, but we learned about this, slicing these lists, where you could put an index, you can put a starting index and an ending index. So you could do this. You could do this. So you could use a slice like this. We want to return the last 3 items. So we know that, we want to return the last 3 items. So maybe we want something like sorted. And how do we want to, not sorted, scores. And maybe we want to return, it's got to be the start to the finish. So how do we know what to do? The first number, maybe we want it to be, we don't know how, we can check how long the scores list is, and we can say length of scores, minus, so if it's 10, so if there are 9 items in it, or if there are 10 items in it, no, 9 items in it, there are 10 items in it, then the length is 10, but 9 is the highest index. So if we were trying to get the top 3, it would be 9, it would be 8, 7, and 6. So we could do what, like the length, like -2, -2 or 3 or 4. Would it be 4? The length, if it was 10, yeah, -4. To basically get the third from the last item, to start from there and go up to maybe like -1. Maybe that will work. So basically I'm basically telling it to go. I don't know how many items are in the list, so I can't say go from number 7 to the last item. Oh, yes, I can. Yes, I can. This is how you would do that. You basically do a slice, open-ended slice here, and it would say go from whatever number is here to the end. So, but we don't know how many items are on the list, so we need to like do some math to determine that. So let's try this real quick and see what it gives us. All right, so we actually passed one. We were actually able to get one to pass. And so let's see which one is passing now. Was it the last one? Let's see what our output is for some of these. I guess we got the last one to pass. All right, but this one is first element, different element. So we got 20, 30, 20, 20. So it looks like we returned 4 items instead of 3 items. So maybe we have an off by 1 error. So we have 1 extra item. So maybe let's try to go 3, which makes sense, I guess. So we change it to 3 and run it again and see if this fixes our problem. So it's fun because you can kind of use these to get closer and closer. So this time it's not enough here. 70, 90, 100. All right. Here's our problem. This is exciting. Our problem is that it's expecting them in an order that is reversed from what we have. We're getting it. We're getting it here. 10, 20, 30, but they want 30, 20, 10. And this is basically with the way that we decided to do this. And this is why using the test to guide you helps, because then we could have looked at them to know that it was going to be looking for it in this order. So we could have sorted them accordingly. But no problem, not a problem at all. We just learned how to reverse them. So look at how immediately applicable us trying that reverse thing was. Because I had never used it before, but look at that. It became immediately applicable. Reverse equals true. So we're reversing everything, and let's just see if reversing everything gives us what we want. Pytest. I keep forgetting the name of the file. All right, still 3 pass, so it doesn't look like we got what we wanted. Not a problem, not a problem, not a problem. Let's figure out what's going on here. I really like this problem because there are a lot of, they've incorporated a lot of caveats here. So this is a little bit different. We got 10, 10, and we got 0. We got some low numbers now. We're not even getting the same numbers now, 40, 30, 20, instead of 40, 40, 30. Okay, we're not even getting the same numbers now. Why is that? Think about what we just did. We were first sorting everything from low to high, and then we were grabbing the last 3 numbers, the highest 3 numbers to return here. But it needed some different output. So we went in and we reversed the way it was sorting. So now instead of going from low to high, it's now going from high to low. But we didn't change what we were returning. We are still returning the last 3 items in this list, which are now the lowest items in the list. So we need to change the slice in which we were returning right here. So instead of returning the last 3, we need to return from 0. We don't even need to put 0, but 0 to length. Actually, we know if we're starting from 0, we know that that we can do up to 2. So let's start with this. So like 2 is going to be the 3rd spot. So this will return the first 3 items. So 0, 1, and 2. Actually, I don't remember if slices are inclusive or not. Let's find out. We'll find out right now. So I don't know if it returns up to 2 or up to or equal to 2 or just up to 2. Let's find out. Whoops. Back up. I think they are not inclusive. All right, so it looks like it's not inclusive. It's only returning 2 things, but this looks better. So let's look at our output. This one looks like we're still gonna have to manage expected 100, but it got 40, so that's weird. Let's check that out. This one looks like it gave back 30 and 20, but it was supposed to be 30, 20, 10. So we know we're only getting back 2 items, so it looks like it's not inclusive. 190, it was looking for 190 and 70. That looks promising, that looks good. 40 and 40, 40, 40, 30, this looks good, like we're really close. So let's go ahead and modify our code again. Let's go ahead and make sure that we make it inclusive. So from the 0 item to the 3rd item, which will give us 0, 1, and 2. And let's run this again and see if we have some more passing tests. And look at that. We instantly have 6 passing tests. So everything else is working except for this one. Why is this one not working? This says has personal best, scores 40, 170. Oh, this is personal best one. So this is not the top 3. We missed this one. This is a failing test for the personal best here. So let's go back up to our personal best function. Something that we thought we were past already. So, oh, it's because we reversed this. I don't know why we reversed this. I didn't mean to reverse this. Basically, I don't know why I did both functions. We just wanted to reverse this one because that's the one we were working on at the time. And this was actually passing before, and now it broke. This is why tests are good. Again, you make changes to code, you make a mistake, it starts to let you know what's going on. Before I went and packaged this up and deployed it and gave it to you thinking that it worked because this was working, and then we moved on to this, and then I broke this, and now like it showed us that it is broken, which is nice. So we'll remove that reverse equals true from here because we were never intending on putting that there. And we run it again, and now we have 7 passing tests. And so this is our code here, and I'm gonna push this to GitHub so that we have so that's available to you. But here it is right here. Pretty simple. This is how you get the latest score of a list. So the last one that was entered, you can just grab the last item with a -1. Personal best, we can still do the same thing. We just have to sort from low to high and then grab the last item in the list. And then here we can do scores as sorted, and we can, sort the list and then grab the top 3 scores in the list, because this one, we had it right before. What we had before was not wrong. It was just wrong for the tests that were written. It would have still given us the same output, but the tests were expecting something a bit different. So we did it from high to low, and we grabbed the first 3 items. So your choice, whatever makes it easier. If you don't like using these -1s or negative indexing, then you might want to do things in reverse and grab the first 3. All makes sense. Again, there are a billion ways to do this, but also just to show you that this will still work if we remove the sorted here and we used our actually, let me just show you how you would use we could use a function like this. We could take our function that we have here that we wrote, and we could make it a function in this file. We could say def sort. Let's call it the mastermind sort. We'll make a function called def mastermind sort, which takes a list, and there doesn't need to be an I because this is a LST is just a variable, and I can paste in what the code that we wrote. So I have this. Let me move this over. Go. So this is our sorting list. So instead of using the built-in sort functions, we can do this right here. But we have to return the list. So I also have to change everywhere it says list to LST. Do I have list anywhere else in here? Let's go find and replace our list to LST. All right. So I just did a find and replace on everything because I needed it to be LST instead. So we're going to pass in the list here, and we're going to do all of our sorting. And at the end, we are simply going to return the new LST to be used. And then here, instead of using that sort function, we can use, we can do scores equals mastermind sort and pass in scores. And yeah, and that will work. And let's make sure that works, and then we can use the other one. So this is us not using sort function. This is us using our bubble sort that we wrote for this logic instead. So let's see if our tests are still passing. Whoa. Oh, that PY. All right, and our tests are still passing. So that's a good indication that we wrote our stuff properly. And so let's do the same thing down here. Let's make sure we change it. And we will actually submit this. We can put in both options. And let's run it again. Uh-oh, so it looks like we broke it. Looks like that might be a good thing. Why do we break it? We broke it because of the reverse ordering thing. So actually, check this out. Let's actually modify. I like this. Well, so either way, it's gonna break one of our options. Either way, let's switch this up to go from. Let's see if we can switch this up real quick. I know we're out of time, but let's see if we can switch this up to actually go from the first to last, because we need the other one to be. We need this one to work, and this one's easier because we can just change this to 0 to grab the first item instead of the last item. So to switch it around. I think you can do like a range, length -1. I think I can do like a -0, -1. So like to go backwards, I think I can go backwards through the list. So, or is it 0 first? So yes. So range, this range function, it'll go from whatever number you start with to whatever number you end with, but you have some other parameters. So we know we can pass in a starting number. I can say, hey, range of 2 to 10, and it'll go every number from 2 to 10. But I can also give it a step. So if I want to go from 0 to 100, but I want it to skip by 5s, I can do range 0 to 100, and then I can put a 5 in there to skip every 5. So the intervals that it'll go at are the 5 intervals. It'll skip 5 at a time. So from this, if I do it this way, I can start at the length of range. So I can start at the end. I can go to 0, and the -1 says step backwards. So go backwards through it. So it should go backwards through it. And I could do the same thing here, except I don't think I need to. I think I can do range num. I don't know why this feels right. Because of the way that this is now working. Let me see this. This is me just messing around now. The pass, what do we get? What was our output here? 20, 30, 40. So this is almost... So this is still opposite. Okay, I wonder if I can put the same range function down here. Why did I do that? I think it's supposed to be length num. Let's see if that works. Okay, I broke everything. That was dumb too. All right, I'll just copy this and let's see if this works. I think this will work. I think. And I'm gonna just go backwards. Index out of range. So, but it didn't fix any of them. Are they all out of range? Because let's see why it's out of range. Oh, because yes, that makes sense. Okay. Trying to think here. Out of time, I just got here. Yeah, time's we usually try to get off at 10. I go for a few minutes after. If you guys have any questions, I'm just messing around now, asking now. I'm gonna push this up to GitHub. I'm just seeing if we can reverse. I'm seeing if we can reverse our output using our own function. So now it's going back. It'll go backwards through it now. Actually, let's edit it in our actual sort file so that we can mess with it. So I can see what's happening. We'll go. This will make for good homework. It definitely will. Actually, you're right. That will make for good homework. So let's actually put some notes in here. That is great. I like that. Let's put some notes in here and let's see if you can figure out how to make it go backwards, especially because I already gave you some of it. So maybe screenshot that or save the time of this so you can go back and see how to go through a list backwards. Let's put it back to how it was. Whoa. Length. I like that. Yes. Well, it's no, I mean, it's important. It is important, but you are that kid. You're definitely that kid in class. I think you've done it twice now. So you're definitely that kid, but it's cool. I mean, you're encouraging everyone to be better. So let's make sure this still works. I think this is what we had it at where it worked. Pytest. Let's see. What is it? Oh, let's see. This one is these are gonna be broken. That makes sense. These are gonna be broken. And this one is not gonna be broken. This should be broken. So perfect. Yes. So let's write some notes really quick. All right. This. Where should we put it? This function is working. This function is working. This function is not working. Whoops, actually, I need to move these up again. This function needs to be updated to sort from high to low instead of low to high. So that's in there. But see if you can actually let's go to new line. If you can modify this to do so and also update the personal, can I tab complete here? Nope. Personal best and personal. Let's go next line. And personal top 3 functions to work with. We modify this to do so and also update the personal best, personal top 3 functions to work with your changes. All right. What's up, old Dizzy? Welcome. Thank you for the follow. Cool. Yes, this is good. Got a little bit of homework here. It's okay if you're completely lost. Really okay if you're completely lost. If you're not, give it a try. Give it a try. The tests and everything are in here. You can run the test. Also, I'm going to leave the sort function. The sort function is here, so you can mess with this sort function if you want to test it out. It's in here as well. So let's go ahead and let's push this up somewhere. Here's what I'm going to do. Actually, we already have a Python thing. So let's go. Whoops. CD documents. Mastermind streams. Python? Pretty sure this is a Git repo already, right? Maybe just Git good is. What's up, L'Assault? Welcome. Thank you for the follow. Where? Really? What is the? Oh, the repos were there. That's whack. I guess I'll move them into the Python test repo. Let's make a real repo. Let's make a legitimate repo really quick so that you guys can have this. We're making too many like random stuff. So Python, this needs to be organized, but we can put it here. So copy -r / exorcism Python. Which one was this? This was high scores. We'll copy high scores here. Get status. Get init. All right. I'm gonna do. Have to get upset before that class. Absolutely. Like I can help you. We can definitely help give you the stuff that you need. Just let me know what you need set up. What are we going to do? We're going to GitHub real quick. I'm going to create a quick repo. And we're creating all kinds of just random repos. We need to clean these up. All right, this one will be called. Actually, no, we created a repo for this, didn't we? For the Python bootcamp. No, we created one for DevOps Bootcamp. So DevOps Bootcamp Jan 2020. This one will be Python Bootcamp Jan 2020. So let's see. That makes sense. Python Bootcamp Jan 2020, because that's when it started. And it's gonna be public. We're gonna create this repo and we're gonna push an existing one. So status vim dot get ignore I don't know why this .vs code is file is here, but we're gonna ignore it. All right. We're gonna add everything because this is all the stuff that we've done so far, and we can update and put everything in folders and all that stuff. But this one, we know this one is the high scores folder. Actually, let's move that into. Let's clean it up a little bit. Make their exorcism, and we're gonna move high scores into exorcism. All right, a little bit cleaner. Let's, yeah. All right, we'll do that for now. Get status. See what we got here. We'll add it all. Whoa. You added another Git repository. Oh, so your current one. Which one is? Oh, yeah. I don't care about this nihilist one. Actually, was it remove? I don't want nihilist. I'm gonna delete nihilist. Actually, rm-rf. Where is it? What did it add? What did it? Should have read that. Definitely should have read it. Oh, in get good. It's in get good. Okay. We're deleting this repo anyway, so we're gonna remove that file because we're deleting this repo. RF get good. All right. Added all of our work to repo. Remote add, git push, upstream origin. All right, mastermind. There we go. That was a lot of work real fast. So it should be there. So I just wanted to get it up there so you can grab it because again, everyone's time is important and I know you want to go relax. So here is the link to the Git, this Git repo. You can clone it, you can download it. And we are going to be, so what we just did tonight is in this exorcism folder, and all the high score stuff is right here. So everything that we did tonight is right here. You can see the sort code that we have here. You can go back and see this is all the exorcism stuff that we have right here. See if you can, read through this comment here and see if you can solve that. See if you can solve it. Talk to each other. Try it out. If you can't, it's not a big deal. Google as much as you can. Look around. See if you can find the answer. But besides that, we are good to go. We had a little bit of fun tonight. We solved some problems. We tried a bunch of different things. We learned how to do sorts. We learned how to reverse sorts. I didn't even know you could reverse sorts using the sort method in Python. So we learned about sort and sorted. Sorted needs to be assigned to another variable if you want to save it. It does not modify the underlying list, but sort does. Other than that, we learned how to use exorcism a bit. So hop in here, and it's okay to hop around. You do not need to go in order. Some of these are a lot harder than others. Are a whole lot harder than others. Some of these are really fun. I remember the Hamming one being pretty fun. Same for I like this one. Like the Lund's algorithm has to do with like credit card numbers and stuff, and it'll make you feel kind of smart once you figure it out. But mess around. There are medium ones that are easier than some of the easy ones. That's why I don't really like the easy designation. You're like, oh, this is a lot easier, but there are medium ones that are easier. And also they're not in order. So you can see here some medium ones come before other easy ones. So there are lots of easy ones on here. So jump around, try one for a while, see what you can learn, go to the next one. You will learn a lot even by going through 20 of these and never completely solving one. You'll learn a lot by just doing your best to solve it and to think about the problem. So go ahead and do that. Do as much as you want. Oh, that's what I wanted to do. They have teams in here. Teams edition. Let's create a team real quick. Create a new team. This team is going to be Mastermind Academy. Choose avatar. We need a cool avatar. Best avatar ever. I should have expected that this will come up, and we are going to choose this one because it just feels like a good one to have. Save image as, let's put it in pictures. Our avatar. And you guys can join this. I don't really know what a team does. I just knew that they had teams. I think we can solve problems together and maybe we get points for it or something. But yeah, it should be fun. Let's see, Python instruction. Exorcism, choose pictures. Is it by date? Can just go by date. Our avatar, open. Great team. We got a team created. Your solutions members. Allow joining via URL. Here we go. You can join the team via this URL. Join up. Let's solve some stuff. It looks like we'll be able to see each other's solutions. So that's really nice. Actually, this is pretty cool. So feel free, join up. And actually let's add that as a chat command so people can join later. What is it? Commands, add, exclamation point, exorcism team. Paste that in. All right, so now people can type in exorcism team. I would just do exorcism, but I think I already have a chat command for exorcism, for the link to exorcism. So we'll add that in there. So if you want to add, there you go. Join up. We are gonna do some cool stuff. Oh, man, you guys are fast. Definitely. All right, cool. That's it for tonight. You guys are 6 weeks down. Everyone, we're 6 weeks down. You made it through 6 weeks of 12 weeks. We got another 6 weeks to go. We're starting to solve problems. We're starting to build things, do some cool stuff. We're going to get into some projects soon. We're going to learn, about error handling. We're going to learn how to mess with files. We're going to learn how to do some automation, how to, manipulate files and make some tasks easier. We might even learn a little bit of like web scraping and stuff too. yeah, it might be pretty cool for that. Next week, if you're in the the DevOps Bootcamp, we'll be finishing up the last two parts of our AWS series as well. So if you are interested in cloud computing at all, we're running through that. So you can catch up on those things if you'd like. But that is it. Everyone enjoy your night. Again, if you're in the Baltimore area or DC area or just, I don't know, Hack Baltimore is pretty cool. Like this is not like a sponsored thing or anything. I just came from an event with them where they gave me all this stuff. And it's really cool. Like using, using a platform to solve, issues that a city has. It's pretty cool. So I don't know, just a little plug for them. Maybe I'll get some more information about it. But I do plan on putting together a whole team to actually go to the hackathon and like, let's build some stuff. So if you ever want to do a hackathon in like May, it's going to be a pretty big hackathon. Come on to Baltimore and let's have some fun. But that's it. System admin, new to Python, learning, use for automation, putting together. Appreciate that. I really appreciate that. So I'm from was it the Prampa? Yeah. Well, sorry if I mispronounced your name, but I'm from a sysadmin background as well. So a lot of the things that I do come from that aspect of things. So that's why I even included a lot of the automation with Python section because like there's some cool things you can do like from that side of things. So I'm glad you're gonna find that useful. But that's awesome. Cool. You got the name right. Oh, cool. I got it. You're the only person who's confirmed whether or not I got it right. So I'm 1 for 1 or I'm like 20 for 20 because I'm just going to assume since no one confirmed. But that's it for tonight. Who's online? Anybody cool online? Is Dowright or anybody cool online? Who's on? Anyone on? What's up, Chatterbox? Welcome to the channel. Thanks for following. I waiting for your name to pop up. I think it was Cardoza. Welcome to the channel. Sorry, we are signing off now. What's the hackathon link? Great question. Let's see. Baltimore. Wait, what is this? Hack Baltimore. Man, I forgot that fast. Hack Baltimore. But also, like, just if you have any, I don't know, even if you don't live in Baltimore, you can submit ideas for people to solve. There's a few different categories to kind of solve. And again, obviously we're doing education stuff. I'm passionate about education. So I'll probably be trying to do something to, be involved in education and how to, help that out in Baltimore. I actually done a lot of stuff with Baltimore City schools. Like I was like on the board at one of the schools, like just trying to figure out like what to do. And there's so much red tape. There's so much bureaucracy on like getting simple things done. It's pretty interesting. It's pretty like the challenges are they feel self-inflicted almost. It's like there are people ready to help, but like they're like not allowed to help. Which is really interesting. So I think this is going to be very fun to kind of be able to see how you can like color outside the lines to be able to get some stuff done. So I don't know. I just think it's really cool. The initiative is really cool. There's a lot of important people involved. Like people are on notice about this, and these are actually funded. Like the ones that win, the things that win are actually going to be funded projects for I think 2 years. They're actually going to be funded projects for the stuff that wins. So the stakes are kind of high here. Like the goal is to not just go to a hackathon and work on something for a weekend and then nothing come of it. Like they want these to be solutions that can be that can be lasting. And to me that's amazing. I really like that. Yeah. Yep. All right, what's up, Minos in? Welcome to the channel. Thank you for the follow. Who's online? We gotta go with I don't see anyone. Does anyone have anyone besides Prime Begins always on? I always just send over there. I feel like there's no reason not to raid somebody, just in case someone wants some more knowledge. You got some time on your hands. Someone who does tech. The Prime Begins show is just entertaining to me as well. Like I was watching while I was doing some work the other day, and like I learned a ton. Is that right on? Because we did Prime Begin yesterday. I don't see if that right's on. We can go to Dowright for sure. Dowright is live. Let's head over to Dowright. You all are obviously free to go wherever you'd like. But we'll head over there. What's up? What's that? Tara Thierry. What's up? Welcome from New Orleans. I haven't been down there yet. We were gonna come down there this year for my birthday, but bad timing. But that's dope. That's dope. Welcome. All right, we're gonna head over to Downright because we went to Prime again last night. We'll head over there now. So everyone have a good night. Thanks for tuning in for the stream. Hope you all have a great weekend. I'll see you all on Monday. See you later.